Ladies and gentlemen, you're welcome. Especially welcome everybody for today's webinar. My name is Victoria Oluwabumilare. I'll be your host for tonight, and we are really happy to have Mr. Habeebullahi Lawal as our tutor, a software engineer, as our main speaker. Mr. Habeebullahi is a software engineer and he's an educator. So today I'm just like really grateful that we have someone so special on the call, and he'll be taking us through this friendly beginner session. Thank you so much, everybody, for being here today. So in this beginner friendly session, Mr. Bibulai will cover the fundamentals of blockchain technology, which include what is blockchain and how does it work, types of blockchain networks, public, private, and hybrid. Then we have blockchain applications beyond cryptocurrency, smart contracts, and their roles in blockchain. Getting started with blockchain development. Today's event will just be, let's say, 1 hour 30 minutes session, but would like to extend. It depends on whatever the audience, really want, the viewers. So today will be a very friendly one. Just stay tuned and listen very well. So, Mr. Bibulai, you're welcome, sir.
Tonight I'm going to be talking about what the blockchain technology is, and it's in it's in such a way that friendly. Yeah, so that's the point. That's the whole point of this presentation, breaking it down for the beginners. Yeah, so for some people who might be familiar, who might be already familiar with the blockchain technology, it might seem like something basic, something fundamental to them. But yes, it is fundamental, it is basic. And that's because the presentation is such that it will be easy for beginners to understand, absolute beginners, people who have never heard about the blockchain technology until today. So that's um that's the people that the presentation is geared towards. What I have on the screen here is the outline of what we are going to be talking about tonight. So we are going to start with what the blockchain technology is to begin with. We are going to start with that. Then we'll move on to the history of the blockchain. We'll also talk about how the blockchain works, and we'll also talk about the key properties of the blockchain, the characteristics of the blockchain. We'll talk about that as well. Then we are now going to go into a little bit of technicality. We'll do some technical uh, discussion about the structure of a block. We'll also talk about consensus mechanisms and distributed ledger technology, and also cryptography in blockchain. So that's going to cover, those are technical aspects, those are technical things related to the blockchain technology, and they are very, very important for us to understand if we are going to truly understand what the blockchain technology is. And we'll also talk about the types of blockchain, because there are different types of blockchain technologies. We'll talk about those as well, and we'll talk about what the blockchain is other than cryptocurrency, because I can bet you that for every time I have said blockchain since I started this presentation, someone or two has replaced it with Bitcoin in their mind, cryptocurrency in their mind. As I'm saying blockchain, what they are hearing is cryptocurrency. So we are going to talk about how blockchain is not just cryptocurrency, but is more than cryptocurrency. And then we'll also talk about the benefits and challenges of the blockchain technology and the future of the blockchain, as well as the key trends in the blockchain technology as well, the blockchain industry as well. So without further ado, let's start with what the blockchain technology is. And in fact, oh, I should have even asked, maybe you can tell me what you already know about the blockchain technology. Like, what was your idea? What's your belief? What do you know about the blockchain technology? Please just put that in the chat, and then I'm going to see how because I'd like, when I'm teaching my students, I like going from things they already know to things they don't know. So I'd like to relate what you already know about the blockchain. I'd like to combine that and mix it up with what the blockchain really is. And if there are areas of similarities, I'll point them out. If there are areas of differences, I'll make sure I point them out as well. I was talking about distributed ledgers, and I was using Total Filling Station as a as an example. So I said, let's say the management of Total, they want every branch to have the records of the amount of fuel that is being sold across the nation. Yeah. So the Lagos branch now is going to have access to um, the records that are being kept in Abuja, and is also going to have access to the records that are being kept in Port Harcourt and every other state of the country. So in that kind of scenario, what is going to be needed is a distributed network. Now, um, let's what is going to be needed is a distributed network. So you can see on this slide here, there are networks that are three networks are being explained here. So the first is a centralized network, which is the normal network that is common, where you have everything in one, like headquarters, the center of in the centralized network structure. The center is the headquarters essentially. So everything comes from there, everything ends there as well. That's the beginning and the end of the network. While in a decentralized network, there is no absolute center, but rather there are many centers. But in a distributed network, there is no center at all. There is no center at all in a distributed network. There is no center in a distributed network. So in that same manner, the management of Total Filling Station, they just need to have they just need to have they just need to have a system in place whereby the whereby you just need to have a system in place whereby every branch of their filling station is going to have access to the records in every other state. And in that kind of situation, what they are going to use is a distributed network, because because the network is distributed, there is no center. The branch in Lagos can view the records of the branch in Abuja because there is no center. Everywhere is the center essentially. So it updates everything at once. It updates everything at once. So let's talk about let's go back to what is a blockchain. So information is recorded in a block. From I'm talking about the diagram now. The diagram on the right. So the first step is information is recorded in a block, and once the block is full, it's chained to the rest of the blocks in the database, and an empty block is added to the end of the chain to record new information. That's the summary, like in brief. That's what happens on a blockchain network. That's what happens on the blockchain. We're going to have a list of many things that have happened. Maybe you sent money to someone, maybe you gave someone your property, or you created an application, your application did some things. Whatever has happened within a certain period of time, everything is going to be compiled and put in a block. It's going to be compiled and recorded in a block. Now when the block is full, we're now going to chain that block to the rest of the blocks on the blockchain. Yeah, so we're going to chain that block to the rest of the blocks on the blockchain, and then an empty block is added to the end of the chain to record new information. You can think of it like this. Imagine you are the record keeper in a very large hospital, and you are witnessing you are currently going through a large influx of patients, whereby you are having to register new patients every single day. Like a lot of patients are coming to register, but you have these boxes in which you keep files for the patients, the boxes in which you store patient files, patient records. So what happens now is, as you are getting more patients, you are going to be compiling their records, and it gets to a point when the records will be too much for you to hold. So what you proceed to do is to package everything into one carton. Yeah, just package everything into one carton. You pack the records, the files, you put them in a carton, you wrap them with sellotape, and you put them on the shelf. That's what the blockchain is. That's like that now. Yeah, that's like uh that's something that's the summary of what happens on the blockchain. So we just take a lot of information, take a lot of data, package them together into a single block, and then we chain them to the block now. We chain them to the block, and it's just there forever. It can't be changed. You can't change what is inside the block once it has been, you can't change what's inside the block once it has been sealed. Once you have sealed the block, once you have wrapped the carton containing all your patient records, you can't change the patient records inside those cartons. That's what it is. So moving on, there are two words that I have used now. I have talked about decentralized networks and distributed networks. Now, a decentralized network is one where there is no single point of failure and control. So think of it like, let's say, oh, you must have had experiences somewhere. Maybe you want to register your SIM card, or you are trying to register for JAMB or something like that. And then they are going to tell you something like, oh, the server is down, the network is bad, so we can't access this current service, for example. Well, that's what happens when you have a centralized network. That's what happens when there's a centralized network. So once the main server is down, once the headquarters is down, nothing can happen anywhere else. That is a centralized network. And in that kind of network, if, say for example, your network provider, say like MTN or Glo, or let's take Facebook as an example. So if Facebook should have problems with their servers, nobody in the entire world is going to be able to access Facebook. So if Facebook servers should go down, nobody can use Facebook anywhere on the world. That's what happens when you have a centralized network. But when you have a decentralized network, there is no single point which, if it is down, then nothing is going to happen again. No, there is nothing like that. When you have a decentralized network, if one server is down, there are many others that can take over in a decentralized network. As you can see here on the diagram, the second image is of a decentralized network. You can see there are many centers, so to speak. There are many centers, about 1, 2, 3, 4, 5, 6, or 7 centers. Yeah. So if one of them is down, another one can take over. That is a decentralized network. In a centralized network, if you can, for security, in terms of security now, if the centralized network, if the main server of the centralized network is compromised, then the entire network is compromised in a centralized network system. But in a decentralized network system, we can't have that kind of scenario, because if one of the nodes is compromised, then there are others that are still safe, that can still be used. So that one is simply going to be put aside, while the others that are still okay are going to be put to use. That is how that is how a decentralized network makes the network more secure. So say for example, back to the Total Oil example, if if Total filling station in Abuja should get compromised, if their servers in Abuja should get compromised, let's assume that Total is using a decentralized network, yeah, whereby every branch of their filling station has the records of all the other filling stations across Nigeria. So if the Abuja branch is down, or they have been hacked, for example, the Lagos branch doesn't need the Abuja branch. The Lagos branch can simply get all the records of all the other states from any other state. The fact that the headquarters in Abuja is down doesn't mean the entire network is down, but rather Lagos can still get the records of fuel that has been sold from other states, from any other state. You can just go to Oyo State and just get the records. It's still going to be the exact same thing that you would have gotten from Abuja, that is still going to get from Oyo or from Jigawa State. I think, I hope that's clear. I hope that's clear. That's for decentralized network, and the distributed network is similar to a decentralized network in the sense that it doesn't have that center of control as well. So it doesn't have a center of control. So the same copy of everything is going to be the same copy of the records of fuel that has been sold is going to be in every state in a distributed network. So one might be tempted, in fact, we might be tempted to say distributed and decentralized are the same, but the only difference that is obvious to us is in terms of the version or the copy of the records that are going to be present across the nodes. That's what we can say can be different. That's the difference that we're going to have. So in a distributed network, everything is going to be the same. Every single node in the network, that's every single computer in the network, every single branch across the country is going to have the same record in a distributed network. So that's for the network explanation. As we go further into our discussion, these concepts are going to become clearer as we see them being applied to some other scenarios. They are going to be better understood. Now let's talk about the history of the blockchain. How did the blockchain start? What happened along the line? And where is it currently? Let's talk about that for a moment. So some of us here, we might have heard of the name Satoshi Nakamoto. Satoshi Nakamoto. That is the name of the person or group of people that created the blockchain technology. So Satoshi Nakamoto is in the software engineering industry, in the tech world, the blockchain industry. We have settled that Satoshi Nakamoto is probably not a single person. It might be a single person, or it might not be a single person. It might be a man, it might be a woman, it might be a group of people. We don't know. That is still one of the biggest secrets in the world today, in the tech world today, the real identity of Satoshi Nakamoto. That is one of the biggest secrets, because nobody knows who he is. There is no picture of him, there is no photo, there is no identification whatsoever. The closest that anybody that we have is what is currently the closest that we have is what is on the blockchain forum, because they created a forum for Bitcoin. And that was where Satoshi Nakamoto, that was where he used to speak. That was how he was communicating with the whole world. So it was only the few people that were on that forum that actually got to speak with him and hear from him. Aside that, no other person has heard about Satoshi Nakamoto or about who he is. Even the people on the forum don't know who he truly is. So in 2008, an unknown person with the name Satoshi Nakamoto, like I've been saying, he published a paper, or these people, they published a paper, and the name of the paper was Bitcoin, a peer-to-peer electronic cash system. That was the name of the paper. So it's just like a research paper. That was what it was. He published this paper, put it on that forum, and people saw the paper, they read it, and they were just discussing about it. And Satoshi Nakamoto actually presented this as the concept of blockchain as the foundation of a decentralized currency. And incidentally or coincidentally, the time that they released this paper, this Bitcoin paper, happened when there was a financial crisis, like a terrible financial crisis in 2008, where some of the big banks were going bankrupt, and that's one of the shortcomings of of the current financial system that we have. The the big banks were going bankrupt, and Bitcoin now was now being presented as as an alternative. Bitcoin was being presented as an alternative for a decentralized currency. That was what that was like the birth of Bitcoin. Now, the fact that the blockchain technology, the first application of the blockchain technology was Bitcoin. That's why many people hold that misconception that Bitcoin equals blockchain. If you are talking about blockchain, then you are talking about Bitcoin. No, Bitcoin is built on blockchain, but the blockchain is not Bitcoin. There is more to the blockchain than just Bitcoin. We are going to talk about that in more detail soon. Now, in 2009, that was when the actual network was launched. So in 2008, they just talked about it, they discussed about it, and it was presented. Everybody saw it, everybody knew it was very promising. So in 2009, that was when they now actually launched the Bitcoin blockchain, and that was when the first block of the Bitcoin blockchain was mined. That was when the first block, the Genesis block, that was when it was mined. So it was the creation, it was the beginning of the Bitcoin blockchain. And then in October of that same year, the Bitcoin network was launched in January, while the in October, that was when they now published the exchange rate of Bitcoin. So now, when they talked about Bitcoin in 2008, they were presenting it as an alternative to as an alternative currency, yeah, to the dollar and all the other national currencies that we have. So it was now in October that they now published that, okay, one Bitcoin is equal to a certain amount of dollars. Yeah, so it was in October that they published that exchange rate. That was the very first time. So now it was becoming real that the blockchain, that the Bitcoin is coming to replace the normal currency that we were used to. Now in 2010, that was the first time that Bitcoin was actually used. It was in 2010 that Bitcoin was used to perform a transaction in the real world. So now it's no more theory. The Bitcoin, they've already discussed about it in 2008. In 2009, they launched the network. So now in 2010, they are now using this Bitcoin. Instead of using dollars to perform transactions, they are now using Bitcoin. This happened for the first time in 2010, and they used it was actually 10,000 BTC, that's 10,000 Bitcoins, was used to purchase 2 pizzas. That was the very first transaction that happened using Bitcoin. So in 2011, Bitcoin became very, very popular because now, after the first transaction, people were now beginning to adopt it on their own platforms. They were beginning to accept the Bitcoin as a currency for transaction in place of the dollar and all the other currencies. So that happened in 2011, and that was actually the first time that Bitcoin became like Bitcoin had the same value as the dollar. So one Bitcoin was equal to $1 essentially in 2011, because now many people had adopted it and it was beginning to increase in value. Now, before I go further, I should I'll just mention it now, and then later I'll go into more detail about it. That the value of a network depends on how many nodes are in that network. So if there are many nodes on a network, then that network is going to increase in value. Think about it like Facebook. The amount of value that Facebook is going to be able to produce depends on how many people are registered on Facebook. So every account that is registered on Facebook is a node on the Facebook network, for example. So the amount of value that Facebook will be able to provide is dependent on the amount of people on the Facebook network. So now the amount of value that the Bitcoin will be able to provide is also dependent on how many nodes, how many people are using Bitcoin. So the fact that many people are using Bitcoin the value of the Bitcoin started to rise, and then in February of 2011, one Bitcoin became equal to $1, and then something now happened. Something happened which changed things for a while. In June of 2011, there is this dark web. You might have heard about the dark web. The dark web is a space on the internet, but it is not. It's not on the surface level of what we can see. You can access the dark web with Google or Microsoft Bing or your normal search engines like Google Chrome. You can't get to the dark web with all of those. There is a deeper level of the internet, and that is called the dark web. It's called the dark web for many reasons, one of them being that terrible things happen in the dark web. One of those terrible things is a platform called Silk Road. Silk Road, that's the name of the platform. And what happened on Silk Road was it was a marketplace for illegal things. Like, you can think about Silk Road as the Jumia of the dark web, but you know, on Jumia or on AliExpress, you can buy things like bags, shoes, clothes, and the like. But on Silk Road now, you can buy things like guns, you can buy cocaine, uh, all these hard drugs, like terrible things, things you cannot walk into a store normally and go and buy, things that were illegal. So the Silk Road now started accepting Bitcoin as their method of payment. So now this raised some issues that perhaps the blockchain is going to be used for evil, is going to be used by criminals. And that raised a lot of issues. But now, that's where it was in this same scenario that we now got to see one of the benefits of the blockchain network. Because in that kind of scenario, you have already seen that, oh, this technology can be used for terrible things, can be used for bad things, yeah? So what governments try to do, the US government, they try to um, nail down the blockchain technology, meaning they try to stop the blockchain technology. But now, the blockchain is not in one place. The blockchain does not belong to one person. In fact, if I am on the blockchain and you are also on the blockchain, both of us can meet. Like, both of us can have a transaction on the blockchain, and we are not going to know that it is between the both of us. We are not going to know that it is between the both of us. So there was this level of anonymousness or anonymity. So it was very difficult for the US government to do anything regarding the blockchain network. So they just had to fold their arms and eventually come into it by themselves. That is one of the advantages of the Bitcoin, of the blockchain network. So in 2013, we now saw a scenario where in 2013 now the value of the Bitcoin was now $1,000. So one Bitcoin was equal to $1,000 in 2013. So something now happened. You know the way they'll say the stock market crashed. Well, yeah, that kind of thing happened to the Bitcoin network as well, to the Bitcoin, because now after it had reached $1,000, it now crashed. It came down. The value of the Bitcoin crashed. It came crashing down. It reduced a lot, and that was the first bubble of the Bitcoin. So you might have heard some people in crypto. If you're into crypto, you might have heard it once or twice, where they say buy the dip. So that was a dip. The value of Bitcoin dropped for a while. That was the first incident of the value of the Bitcoin dropping. But also in that same year, in April, a guy called Vitalik Buterin, he published a white paper, another research paper essentially. He published a white paper about a blockchain network called Ethereum. Now, the first blockchain network that was created was for the Bitcoin. Now another blockchain network was now being discussed, and this one was called Ethereum, the Ethereum blockchain. That was but this time around, it wasn't going to be just for cryptocurrency. You know, the Bitcoin network was mainly for cryptocurrency. In fact, only for cryptocurrency, just as a digital currency. That was what the Bitcoin was for. But now the Ethereum itself and saying, oh, we are not just going to have cryptocurrency, meaning you won't just be able to use the Ethereum network for transactions, but rather you'd also be able to execute programs on the Ethereum network. something called smart contracts. So it's not only transactions but also contracts, also programs, meaning you can have some things that are going to happen and it is sealed. You can have a contract between you and someone else and it's going to be on the blockchain network. And the fact that it is there on the blockchain network, a smart contract is going to execute by itself. That is the smart in smart contract. It executes by itself. It doesn't need someone to come and say, oh, now you can execute. No, the contract is just going to execute by itself. So there is nobody that is going to breach the contract. Now, that was one of the main selling points for the Ethereum network. In 2014, that was when the Ethereum network was now they launched the network and they raised some money. They raised some money. I'm sorry, just give me a moment. They raised some money for the Ethereum network. So that was where they now that was where they were able to get the funds for the network. And in the following year, in 2014, that was when they launched the actual network. So now the Ethereum network was now operational and you could have cryptocurrency on the Ethereum network, just like the Bitcoin network. And you could also have smart contracts on Ethereum blockchain as well. So you can have a contract between you and somebody. Say for example, let me just give you a quick example. Let's say you want to work for a client. Let's say you are a freelancer, you are a writer, a freelance writer, and you want to work for a client. So you agree with the client that when I finish this project, you are going to pay me $100. So the client puts the $100 in an escrow account. Yeah, it's called an escrow account. So the $100 is no more is not with the client anymore. It's in a temporary area. The only thing that is with the smart contracts. Let's just talk about the smart contracts. So the $100 is now with the smart contract. The smart contract is only waiting to receive the article. Once the article has been received, the smart contract is going to automatically take the $100 and put it into your own bank account. So that's one of the things that the Ethereum network enabled. So in 2015, that was when this happened. And then in 2016, we now saw the use of the blockchain to create organizations. Yeah, so they used the blockchain to create an entire organization whereby there was no single leader, there was no single controller for the blockchain network, for the organization. That was what happened in 2016. And then in 2020, we got to see decentralized finance, which is just like a bank, but there is no central authority now as well. So people were beginning to adopt this in 2020. And then in 2021, that was when the NFTs became popular. You might have heard of NFTs. The meaning of NFT is a non-fungible token. Yeah, the meaning of NFT is a non-fungible token, and that was when it became popular in 2020 and 21. So now you could use NFT. You could buy an NFT, a digital asset. An NFT is a digital asset. You could buy it, and then that NFT is going to have a value which can increase or decrease over time depending on how things go. And then in 2024 now, we are now seeing integration of the blockchain with artificial intelligence. So it is the blockchain is going to be enabled with artificial intelligence, so things are going to get a lot more better from here on. So now that's a little bit about the history of the blockchain. Now let's talk about how the blockchain works. So first, I'm going to start with a high level explanation of how the blockchain works, and then later on, I'm going to talk about how it works from the bottom up. So we in the blockchain network, we have blocks and chains. Yeah. So like I said before, the blockchain is a series of blocks connected by each other and connected to each other, like you chain blocks together. So the blockchain is a sequence of blocks, each containing a list of transactions, and every block is linked to the previous one through a unique cryptographic hash, forming a chain of blocks. So it's such that it's a long chain. It's just one single chain, but the every single block, every single piece of that chain is interlinked. So you can't take one piece of the chain and move it forward and bring another one backwards. No, it's one single chain. It's linear. So everything is in a single line, and each new block contains the hash of the previous block, creating an immutable chain. So what that means is that the every block depends on the previous block. Every block depends on the previous block. So you can't, if you are going to change one block, then it means you have to change what comes before it, and then you have to change what comes before that one as well, all the way to the beginning of the block or to the beginning of the chain. Or you can see it as, if you're going to change what is in one block, then you have to change what is in the next block, and then the next block, and the next block, till you get to the current block as well. So in the blockchain, we also have the concept of transactions or data. Because like I said, it's not only transactions that can be performed on the network, on the blockchain network, but you can also have data being stored on the blockchain network. So transactions are initiated by users, and they contain specific information, and these transactions are grouped together into a block. That is what transactions are. And a cryptographic hash is a digital fingerprint of the block's content. So like I said, every block is dependent on the previous block, and is also the content of that current block combined with the hash of the previous block. When you mix all of that together using cryptography, you get a hash. So now that hash is unique. Once the content of that block should change, the hash as well is going to be different. So it's going to generate a different hash. Let me quickly give a brief demonstration of that. This is the block. The number of the block is 1. It has a nonce, and it also has some data. Now the hash of the block currently starts with 4 zeros, and that is what this particular blockchain network needs. So when I change the data, if I put some data into this particular block, the hash is going to change. So the hash is not starting with 4 zeros anymore, but now we're starting with some other things. So in order for this block to become stable, we need to mine the block again. In order for this block to be acceptable on the blockchain, we need to mine the block. So when we mine the block, you'd observe that the first 4 characters of the hash changes to 4 zeros as well, followed by some other characters. Now this characteristic of the blockchain, here it is. That's it. It has mined the block now, and the block is now stable. It will now be accepted on the blockchain. Now this characteristic of the blockchain is one that prevents the entire blockchain from being compromised. Let me explain it with another demonstration, so it will be easier to understand. Okay, so you can see this is a blockchain. The first block here, the number of the block is 1. The second block is block number 2, block number 3. So we have these 3 blocks up to block number 4 on our blockchain. So this is a chain of blocks now. But you see what happens when I change. This is the first block, the second block. Observe what happens when I change the data in the second block. You can see that the second block currently does not have anything in it. So when I change the data, let me say second block, you can see that the third block also changes, because the third block is dependent on the second block as well. So when something changes in the second block, then it has to change. The third block is also going to change. So when I mine the second block, and now the second block is now stable, I have to mine the third block again, and when the third block becomes stable, I have to mine the fourth block, the fifth block. So I'll keep doing that for all the other blocks on the blockchain that comes after, because now if you observe, you see that it's only the second block that I changed, but that change affected the third and the fourth and the fifth blocks. Like every other block in front of this second block is going to be affected. So that is the immutability of the blockchain. So the content of a block, the identity of a block is dependent on its content as well as the hash of the previous block. So that's what I was trying to explain with the demonstration. So that's the immutability of the blockchain. So now, like we have seen, the security of the blockchain is also very strong because when you attack, uh, say for example, the filling station example, when if the network is hacked from Abuja, it is not going to affect the records in Lagos. You get what I'm saying? It's not going to affect the network, the computers, the records in Lagos. If it is attacked from Lagos, the Abuja record is still going to be intact. So the blockchain is secure in that manner because it doesn't exist in only one place, but rather it exists in everywhere in many other places. So it is very, very secure. Now there's also a consensus mechanism. Blockchains have a consensus mechanism which ensures that it is only valid transactions that will be added to the blockchain. Only valid transactions. We are going to see how that plays out very, very soon. So now a consensus mechanism is okay. So to add a new block to the chain, nodes use a consensus mechanism like proof of work or proof of stake. I'm going to explain what those are. So it's going to use a consensus mechanism to verify transactions and ensure that they are legitimate. So this prevents fraud and double spending by requiring network-wide agreement on each transaction. So these methods ensure that not only valid transactions are added, ensures that only valid transactions are added rather, regardless of any node's identity. So what this is saying is, using that our total filling station example again, if the blockchain of Total from Lagos now, if the Lagos branch of Total is trying to change something on the blockchain, it has to first seek approval from all the other states. So all the other states in Nigeria have to agree with Lagos that okay, yes, we give you the permission to change this thing. Hmm? So for that to happen, there is something called proof of work. So that proof of work is what is going to that proof of work is what is going to what the node that wants to change the blockchain, that wants to mine a block on the blockchain, for example, say Lagos. So it is that proof of work that Lagos is going to show to all the other states that look, I have actually done this work and I have confirmed that it is correct. So now the other states are now going to approve that for Lagos that oh okay, since you have done the work and the work is correct, the results are appropriate, we allow you to create the block. That is what a consensus mechanism is. So Lagos cannot just decide one day that oh I want to create a new block, and it's just going to go and do it without the consent of all the other states. No. So a consensus mechanism makes sure that it is only blocks that have been given the permission by the entire network that are going to create new blocks. So that's going to make sure that the entire block is properly validated. So now there are two main ways of two major technologies for consensus mechanisms. One of them is the proof of work. The proof of work is the old one, so to speak. It's the first one that came out, that was introduced. So proof of work is a technology, is a system where many nodes, they are going to compete to solve a complex puzzle. Yeah. So the first person to solve that puzzle is the one that is going to have the right to create the new block. And when they create the new block and the block has been added to the blockchain, they are going to be given a reward by the entire blockchain. So the blockchain is going to give them a reward. And the proof of work system is computationally expensive. Yeah, so what that means is that the puzzle that they are going to be solving is a very, very complex mathematical puzzle, such that it's not something you can quickly do, but rather something that the computer is going to have to spend a lot of resources doing. Like if you're running it on your computer, you literally hear your fans blowing very hard because they'll be working very hard to solve the puzzle. So, but once they are able to solve the puzzle, they are going to get the right to create the block. And once they create the block and the block is added to the chain, the blockchain is going to give them a reward for their work. So now, um, since altering a block, because meanwhile, this proof of work is the mining process now. It's part of the mining process. Like you saw in that demonstration where I had to mine the block to make the block stable, to stabilize the block after I had made changes to it. So that's the process of mining the block. That is what the miners do. The miners are going to take the contents of the block and they are going to find a puzzle. They're going to find the nonce that is going to produce the given hash, the required hash. So, since changing one block is going to is going to require remining it and all the other subsequent blocks, proof of work is secure, but is also slow and resource demanding. So that is some characteristics of the proof of work system of consensus on a blockchain network. Now, the other method is proof of stake. Now, the other method is proof of stake. The proof of stake system is one in which validators are chosen to create new blocks based on the number of coins that they hold and they are willing to stake as collateral. Yeah. So, you know, in the proof of work system, the way that the miners were chosen was based on how fast they were able to solve a particular puzzle. That's the criteria for choosing them. But in the proof of stake network, in a blockchain network that uses proof of stake as a consensus mechanism, the method of choosing a miner is by looking at how much they have actually staked, how much have they put on the line. So what the miners are going to do in this case is they are going to put a lot of money on ground and they are going to go and gather some transactions, they are going to verify them, and then they are going to come to the entire blockchain network and tell the blockchain that, look, I have this list of transactions with me and I have verified that all these transactions are proper, they are appropriate, they are legal, they are valid. Yeah, I have done all the work. Now, this, look at it. I'm putting some money on the ground, I'm putting some money on the line. If these transactions are not valid, take my money. Hmm? So essentially they are betting on their work. So they are staking their coins and they are telling the entire blockchain network that I have made sure that all the transactions on this inside this block are valid transactions. Now go through them yourselves. If any of them is not valid, take this money. Take all these coins that you have staked, I'm going to lose them. So the entire blockchain network is also going to go through the transactions that this miner has put together, and if everything is validated by all the other nodes in the network, then the block is going to be mined by that miner and they are going to get the reward that is attached to it as well. So the proof of stake mechanism is more energy efficient as it doesn't rely on intensive computation. So it is faster and it is more eco-friendly. So it's eco-friendly in the sense that it doesn't use up much energy in terms of electrical energy. It doesn't use much electrical energy, so it is energy efficient as well. So validators risk losing their staked coins if they act maliciously, incentivizing honest behavior. So that's the proof of stake method of consensus on a blockchain network. So having talked about that, let's talk about the distributed ledger technology. So like I said, the blockchain technology is distributed across nodes and every node on the network holds a complete copy of the ledger, providing transparency, redundancy, and resilience. Even if some nodes go offline, the ledger remains accessible across other nodes. So you can think of the total filling station example again. So the records are kept the same, like they are kept synchronized across across all the branches in the country. So even if one particular state is offline, you can still get whatever you want from another state. So that is the distributed characteristic of the blockchain network. So now I've talked about cryptography, and I have said that the blockchain is secured by cryptography. Like the block, a single block, every block is secured by cryptography. So cryptography is the practice of securing information by transforming it into a format that can only be read or processed by authorized parties. And this involves using encryption and decryption using algorithms and keys. So when we are now talking about the blockchain network, when we are talking about the blockchain, two aspects of cryptography are very important. The first is hashing. Yeah, hashing. So from the demonstration that I showed earlier, I'll just show it again, um, so that we can see we can see clearer what it is. So if you look at a single block, if you look at this single block, you see that it has a hash. This block has a hash. When I change something that is inside the block, I have to mine the block. It gives me a different hash. Now the hash is different. So in blockchain technology, it is this cryptography method, this hashing of a thing, that is what is used to take all the things inside the block, the nonce, the number of the block, and the content of the block, including the hash of the previous block. So all of these data, it just summarizes everything into one string, into one piece of information, and that information is called the hash. So that hash contains all the other content of the block, including the number of the block, the nonce of the block, the data in it, and the hash of the previous block. So that hash is unique to that block, and you cannot have a block, more than one block cannot have a single hash. So a hash is unique across an entire blockchain technology, across an entire blockchain network. A hash is unique. So that is hashing, and there's also the concept of digital signatures. So digital signatures is just like uh, it's used to verify the sender's identity. That's what a digital signature is. So it's just like saying I want to pass a message across to you, but I don't want another person to see this message. So what I do is I take that message, I lock it with a private key. I'm going to create two keys, a private and a public key. Yeah, I'm going to create after I have made the message, I am now going to lock this message with my private key. Yeah, that's what I'm going to do. Now anybody that I want to be able to see that message, I'm now going to give them a public key. So when you have a public key, you can only view what is inside the block. For example, you can only view the content of that message. But with a private key, you can not only view, but you can also modify. So the fact that it is only I who created the message that has the private key, it means that every other person can only see what is inside, but they cannot change what is inside. So that is another cryptography concept that enables the blockchain. So that is for cryptography in the blockchain technology. Now, I've talked about the structure of a block, but I'll just go over it again. So the first thing that it contains is the block header. Yeah, the block header. It is inside the block header that we have the hash of the previous block. We also have the timestamp of the block and the Merkle root. The Merkle root is just a representation of all the previous blocks summarized into one character, into one string. That's what the Merkle root is. And we also have the nonce, and the nonce is in proof of work systems. The nonce is the answer, essentially. That's what the nonce is. The nonce is the answer to a challenge of mining the block, and the difficulty target is just that's the target. So when you want to mine a block in a proof of work system, the difficulty target is the answer they are trying to reach, but the nonce is now your solution to that challenge. So these are the things that are contained in a block header. And after that, we also have the transaction data. This is now where all the transactions that we are recording, This is where it's going to be inside the transaction data, inside the transaction list or the data list. So it could contain smart contracts, it could contain data records or transactions in financial blockchains. And there's also the block hash. The block hash is a unique identifier that is generated from the block's contents, like I have said before, and it serves as a fingerprint for the block and ensures that any modification within the block is going to change the hash, and that makes tampering the block detectable. So whenever a block has been tampered, it is going to be detectable. Now I'm going to show another demonstration now. Just give me a moment. I have another website here for demonstrating this. And I think I'm going to make the links to these websites that I'm using for these demonstrations. I'm going to make them available at the end of the presentation, so that you can go through them yourself and um, you can explore, just play with them by yourself. So I'm just going to, you can see here I have a blockchain, and this is the first block. This one that we can see here that says welcome to blockchain demo 2.0. This is the first block on this blockchain. Let me refresh the page so we start afresh. And so you are going to get the concept from the ground up. I'll just close this. So yeah, this is a fresh start now of a blockchain. So this is the very first block. It has been mined and it contains a data. This data says welcome to blockchain demo 2.0. Yeah. So if I want to create a new block, I just have to put some data here. Let's just call this second block. So if I click on add new block, you can now see that the block now contains some other it contains the details of the block. So talking about the structure of the block, the first thing that I said it contains is the block header. So inside this block header is where we are going to have the previous hash of the block. That's what we have here, the previous hash of the block. This is the block header here. And we also have the transaction or the data list, essentially what is in this place. That is the second part of the block. And the third part of the block is now the hash of the block itself. That is what we have here. That's what we have here, the hash of the block. So those are the three main parts of a single block on a blockchain. Yeah, those are the three main parts of a single block. So we have the block headers, which contains the previous hash and some other detail. We also have the transaction list, which is whatever is inside the block, and then we also have the hash of the block, which is the hash of the entire block, which is combining the content and the previous the hash of the previous block. So that's what is inside a single block. So I'll just switch back to the slides so that we can move on. We're running out of time. So the transaction process. Now I showed you what's it called, how the blockchain works. I showed you from the top to the bottom before. Now let's take it from the bottom. Let's take it from a user's level now. So the first thing that happens is a user submits a transaction. Yeah, a user submits a transaction. So maybe you want to send some money to someone. This is the stage where this happens. You submit the transaction details to the blockchain. So now the second stage is where the validation occurs, which is where all the nodes in the blockchain network, they are going to verify that, let's say you want to send some money to someone, they will first verify that you have that amount of money. For example, I'm using financial blockchain to explain this. So the blockchain network is first going to confirm that, okay, yes, you have the amount of money that you want to send to the recipient, and is also going to verify that the recipient is ready to receive that money that you want to send to them. That's what happens in the second stage. So the blockchain is going to validate the transaction. It's going to ensure that, oh, okay, the transaction is valid, is legal. So once that has happened, the block is now going to be created by a miner. So someone that is mining on the blockchain, the block is going to be created by them, and that block is going to include your transaction. Because it has now been validated, the miner can now the miner can take it and put it in a block because it has been validated. So they are going to create the block. So when the miner creates the block, the miner is now going to show it to the entire network again and say that, oh, I have compiled a list of valid transactions and I have made them into a block. So the entire network has to agree that everything that is inside that miner's block, including your own transaction, is valid. So once that has been done, the block is going to be added to the chain, finalizing the transaction. So that is how it happens from the ground up. Now, that's how it happens from the ground up. So, moving on to the different types of blockchains that we have. The first one is the first type of blockchain that we have is the public blockchain. Yes. So these are blockchains that are open to anybody who wants to participate, so they can read and add to the blockchain. And the public blockchains are also decentralized, with no single entity controlling the network. That is a public blockchain. And the public blockchain is also transparent. It's fully transparent. So everybody on the network, like every node on the network, can see what is happening. It is not there's no confidential aspect of the blockchain, of the data that is on the blockchain. There is nothing confidential. Everybody can see everything, so it's fully transparent. Yeah, and it's also secure, as the more amount of people that is on the blockchain, that is on the network, the more difficult it is to tamper with the data on the blockchain. So public blockchains are very, very, very secure. Now, apart from public blockchains, we also have private blockchains. Now, private blockchains are restricted to authorized participants, and they are controlled by a single organization or a consortium. A consortium is just a group of organizations. So that's what a consortium is. So a private blockchain is centralized, and it is partially decentralized. So because it is private now, and in a company there's hierarchy. Yeah, there's hierarchy. Some people are higher than others. There are seniors and juniors in the hierarchy of the entire organization. So it is partly decentralized in the sense that only some nodes are going to be able to access the full contents of the blockchain. Only some nodes on the network, so not every node. So it is partially decentralized, and is also limited, as data is only visible to authorized participants. So it provides privacy for sensitive information. That's the advantage of private blockchains. So sensitive data can be kept hidden from all the other nodes on the network. That is the one of the advantages of a private blockchain. And it can be highly secure within the network, but it relies on the organization to protect against external breaches. In public blockchains, you don't have to do take any extra measures for protecting the entire blockchain, but in a private blockchain, you have to do the work. You have to do the work to make sure that your blockchain is not going to be compromised by hackers or any other person that has malicious intent. So it's the public and private blockchain is suitable for enterprises that require data privacy and control, such as supply chain management, banking, and healthcare records industries. So another category of blockchains is the permissionless and permissioned blockchains. So permissionless blockchains is more or less like a public blockchain. Um, is permissionless blockchain A public blockchain is an example of a permissionless blockchain, which is open to anyone without allowing anyone to join the network, and they can validate transactions and participate in consensus process without needing any permission from anybody. So that is what the permissionless blockchain is. Essentially, it gives everybody has equal rights in a permissionless blockchain. Yeah, everybody has equal rights in a permissionless blockchain, and it also has a decentralized governance. So um because there is no need, like there is nobody that is deciding who has the permission to do what, it is fully decentralized. So everybody has equal rights. There's nobody is the master of the other in a permissionless blockchain. And again, it is publicly visible to everybody, just like on the public blockchain. But this time around, a permissionless blockchain is slower and less efficient than the public blockchains. They are slower because everybody on the network has to validate the transactions. Everybody on the network has to make sure that all the transactions are valid. So it is slow and it is less efficient for on the permissionless blockchain. While on the permissioned blockchains, it is only authorized participants that can join the network and validate the transactions on the network. So permissions are granted by a central authority or a group of authorities, a consortium. So controlled a permissioned blockchain has controlled governance, and transactions can be kept private from non-participants. So just like the private blockchain as well. That's what the permissionless blockchain is. A permissioned blockchain rather is. And we also have the consortium blockchains. So you've had this before, consortium. So a consortium is just a group of organizations that come together and then they create different blockchains for different things. That is a consortium. So shared governance occurs in a consortium blockchain, and it is partially permissioned because it is only some people that have the access or the privilege to take some actions, while there are some other actions that every other node can also perform them. So it is partially permissioned as well. So that is for the types of blockchain. So now you might have heard that the blockchain is equal to the Bitcoin, or that blockchain is equal to cryptocurrency, but that's not the case. So the fact that the first use of the blockchain was for the Bitcoin technology, it gives us that misconception that blockchain is only used for cryptocurrency. But there are many other uses for the blockchain technology. You can look at financial services, which is currently what everybody thinks is for. So decentralized finance is one that uses the blockchain technology to build systems where people can perform financial transactions, but you don't have to trust anybody. You don't need to trust anybody. You don't need to trust anybody for anything. Everything can happen from behind the scenes. That's decentralized finance. So nobody has control of whether you can borrow money or not. Nobody has control of whether you can send money or not. So that's decentralized finance. We also have supply chain management. So you can use the blockchain technology for supply chain management. Let's say you are running a service like Jumia or AliExpress. So from the moment of someone creating an order to the moment the order is fulfilled, when they get their product, you can use the blockchain technology to monitor every stage of that process, because someone who has not received a product is not going to say they have received it. Like, they won't be able to someone who is supposed to deliver the product cannot possibly create a fraudulent record that shows that they have delivered the product when they haven't actually delivered that product. So supply chain management is also enabled using blockchain technology. We also have healthcare, because the records of patients, of individual patients, is very sensitive. It is sensitive data. So the the privacy that the blockchain technology enables is very, very useful for the healthcare industry, because now the fact that you can gatekeep the patient records is going to be very, very beneficial using the blockchain technology, because now you can make sure that only authorized people, let's say doctors or nurses, only those people will be able to view the patient's records. So that is one application. Another application of the blockchain technology that is not cryptocurrency. And again, smart contracts. Like I said, they are self-executing contracts. So when you have a contract with someone else, the terms of the contract, once they are met, automatically the fulfillment of the contract is going to follow. So if you want to buy a house, for example, and you are using smart contracts, the contract is only going to be expecting that you pay them, and once you pay them, it is going to transfer the ownership of the house to you. So that is a smart contract. So whether or not the person that you want to buy the house from, whether or not that person is actually trustworthy, you don't have to bother about that. The blockchain technology is going to take care of that. So that is a smart contract, an example of applying smart contracts. So there are also other applications like voting systems and intellectual properties, and also digital identities. So just like NFTs are a simple example of digital identity, because now you're going to take something and you're going to give it an identity that is digital. So those are other applications of the blockchain technology. So some of the benefits of the blockchain technology is the security that it comes with, also the transparency and the reduced costs, and also we also have faster transactions and decentralization. So the blockchain technology is very very beneficial because of these five, at least these five characteristics. So it is very very beneficial because it is secure, it is transparent, the cost of performing transactions on the blockchain is lower than if you had to do it in real life. Let's say you have to hire a lawyer or things like that. So the cost of performing transactions on the blockchain is lower, and it is also decentralized, meaning nobody has absolute control of the entire network. But now it also has some challenges. One of them is scalability. So when a network is scaling up, when more people are joining the network, it will become more difficult for the entire network to like the entire network is going to be consuming more energy. So that is not a good thing for the earth. So scalability is an issue, and energy consumption as well is also an issue. So the more people you have, the more energy is being consumed, and the more energy is being consumed, the more harm that is done to the earth. So there are also regulatory and legal concerns. So that is also another challenge that the blockchain technology currently faces. Although some people are making moves to make sure that this is also overcome. Now, these are okay. So these are the links to the websites that I have been using to demonstrate the blockchain. So the demonstration of the blockchain, you have blockchaindemo.io as well as the other one. So on the second one, this and that's brownworth.com, you can find demonstrations for a single block for a blockchain as well. You can also find um the what's it called, the cryptography demonstration as well for the hashing. It's also on that platform as well. Now the road ahead for blockchain is, like I said, I said one of the challenges of the blockchain is the scalability. So one of the solutions that is currently being proposed is sharding. So sharding is where, instead of having one block and then you have a list of transactions inside that block, with sharding, what they are aiming to do is to create sub blocks. So every single block is going to have a sub block, like you're going to have children blocks, not blocks that will come after it, but some other blocks inside it, rather, so to speak. So every single block is going to contain many other other blocks. Yeah. So that's what sharding is. That's what sharding is. So you are creating shards. You are creating shards. You break it into smaller pieces that you can use separately in a single block. That is what sharding is, and that is one of the solutions for scalability. Now, energy efficient consensus algorithms like the proof of stake is also being widely implemented now. So proof of work, that's why I said proof of work is like the old one. Proof of stake is less energy intensive, and there are also moves to ensure that the blockchain technology is regulated just like any other industry. But the amount of regulation that is going to come into the blockchain technology is not going to be the type that is now going to stifle development and improvement in the blockchain technology. So these are some key trends in the blockchain technology, things that you might have heard of before, like decentralized finance. So decentralized finance is, I've already explained decentralized finance before, but let me just go over it again, although we are running fast out of time and I still have to take your questions. So decentralized finance is where you have a financial system, but it does not belong to one person. Nobody has absolute control of it. So everything that you can do in a bank, you can do with a decentralized finance platform. You also have non-fungible tokens, NFTs, which were once very, very popular because they were of high value. And we also have interoperability between blockchains. So like I said, you can have many blockchains. But now, interoperability between blockchains is where we now have a blockchain that is interacting, fetching data from another blockchain. So not only from the current blockchain, but from other blockchains as well. And we also have central bank digital currencies. This is a move by banks and governments of different nations to adopt cryptocurrency, to adopt blockchain technology as a method of creating digital currencies for their citizens, for their clients. So, recommended reading for blockchain technology. This book, this single book that I have outlined here, The Spatial Web by Gabriel Rene, it's a very, very good book for a beginner. You know, there are many books that I could have recommended, but I feel like those ones are technical, they are complicated for beginners. But this one is it provides a very simplistic approach, and it presents the blockchain technology without all the technical jargon, and it shows you like how important, how beneficial the entire blockchain technology is, and it spares you all the detail the of the inner workings of the blockchain technology. So from if you read this book, you'll be able to better decide whether or not you want to learn more about the blockchain technology. So it's a very, very good introduction. In fact, some people read only this book and then they decide, like you can make your decision whether or not you want to explore the blockchain technology further by reading this book, like just this one book. So it's a very good book, and it is my recommendation for further reading for the blockchain technology. Thank you very much. Miss Victoria, the floor is yours once again.
Wow, wow, wow. Thank you so much, Mr. Bibulai. That was a very wonderful presentation. In fact, even me that I don't even know anything about blockchain. Should I say I don't know anything about this session was like, wow. I can't really words can't express how like grateful I am for attending this session, for being host of this kind of wonderful session. So it's really a great one. Thank you so much once again, Mr. Bibulai. So to recap what we have covered today, we covered what is blockchain and the core concept, the fascinating history of blockchain, how blockchain works, including key properties and structure, the consensus mechanisms and distributed ledger technology, the crucial role of cryptography, the various types of blockchains, expanding blockchain application beyond cryptocurrency, benefits, challenges, and the future outlook, emerging trends shaping blockchain and landscape. So all of it together. So we really covered a lot today. And for people that have questions, if you have questions, you can type them while there'll be background, song. And you can also share what you've learned today in the session. We'd like to hear from you.